Right, so welcome to the webinar today that I'm hosting. This is on the Spatial Editor and some tips and tricks for when using this powerful tool within Petrosys' mapping module. So the agenda for today is fairly easy. We'll go into a demonstration and I'll demonstrate some of the tools available to you within the Spatial Editor. And then once that's done, we'll just have a brief summary over some of the things we've looked at. There'll be an opportunity at the end for any questions, and you have the option to ask some questions as well as I run through the webinar. Right, so I'll jump straight now into this demonstration. So I have Petrosys open here, and here I have a presentation quality map. And I'm just going to launch the Spatial Editor by using the Edit Spatial Editor option. You can also launch it from this icon within the icon menu just here. So when we open the Spatial Editor, this is the window here that you will see. Now you'll also notice on the right hand side of the screen here, I also have this menu here. Now this is quite a useful menu for when looking at any data, as it will display in attributes, coordinates, and any other information about the shape. And this menu, the table-based menu, is toggled on and off through this option here. I find it extremely useful to keep this option on. But we'll start by just dropping and dragging a file geodatabase that I have here. And I'm just going to start by showing you some of the right mouse button options that are available to you within the table-based views. Now to help illustrate this, I'm just going to toggle on to our dynamic map sheet within Petrosys. I'll click OK through that. So I have a number of license blocks here in the North Sea, Irish Sea, up into the Barents Sea, and around sort of off Denmark as well, and Germany, and a few onshore. But I'd like to filter these ones specifically by an attribute. Now I can do this within the Spatial Editor, and the best way to do this is to change your views in this option here in the shapes, and I'm going to look at the country codes. And what I'll do is I'll quickly just hide the shapes and I'll start filtering the data. And I'm going to go and filter this data specifically by countries, and the specific country I'm going to look at is Norway, as this is the region here that I will be looking at. So let me just add that filter, and I'll put NOR. And I can quickly just show all those filtered shapes, and it's easier, especially with a file geodatabase, which could be very extensive in the amount of data that it has available within it. It's a quick way of just focusing down on a specific subset of that data that I'd maybe want to concentrate on and edit, and I can do all that within the Spatial Editor. But we're going to just jump back to the map that I started at the beginning. So I'll select my map sheet, which obviously gives me the presentation quality that we have in Petrosys. And we're going to have a look at some contours to start with, the ones that we see displayed here. I no longer need this file geodatabase, so I can just close the current layer just by clicking the minus button. And I'll just drag these contours in. And the area I'm just going to focus on is this area here. And for the means of this webinar, you can see that a number of these contours here do not actually snap right onto this fault just here. So what I can do is I can select a batch of these by either just drawing a square, left mouse button click, and just drop and drag. And you can see everything that falls within that square has been highlighted red. I also have options as well to use the control button, and I can just click to remove any contours, or alternatively just click to add as well. So these contours in questions that don't snap onto the fault, we have this option here. We have the snap lines to faults. Now, as you can see, it's not active here. Now, that is because we need to actually have the fault file in question that we would like to snap to active in the Spatial Editor. So I'll just select my contours again. And as you can see, we now have this icon active. By clicking on it, we have this crosshair with what we call the edit circle around it. Now, I like to think of this as a sphere of influence. So anything that falls within the circle, it means it will be edited. If it falls without the circle, that item will not be edited. Now, I can make this edit circle smaller and larger by either just dragging this bar here, or alternatively, I can use the shortcut keys and hit Shift and use the scroll button in the middle of my mouse just to make it smaller or larger. So just make it larger here, just to encompass all those. I'll just make it a bit small because I'll show you some of the options. So to start with the snapping options, we have extrapolate on here. So just by clicking on these contours, we just continue those contour lines on the trajectory they're on until they snap onto the fault in question. The other option you have available is a bend option. So this will then just bend the contours until they snap onto the fault in question. Now, you also have other options available to you within the editing of contours. We can bend, and we can move around contours, we can just smooth them. You can maybe delete sections and redraw also. And if you do this with your contour files, you then have the options within Petrosys, within our surface modeling module, to then regrid these contours and produce a new surface, a new grid from those contours in question. Looking forward to future versions of Petrosys. The next version we'll be releasing is 17.8, and within this we'll hopefully have a tool called the Surface Editor, where when you edit, say, your contour file, you can then see these edits you've made reflected back in the grid surface that is linked. So now that I've just snapped all those contours onto the fault, I'm going to just show you some of the ways that we can create a polygon, which could be used maybe in volumetrics in Petrosys, and how we're able to do this from a number of different features. So within Petrosys, if it's a closed contour like we see here, it's easy enough just to export that to a polygon. It's a right mouse button click and export to polygon. But in the case where we have a fault here, which is acting as maybe a seal of some sort, and we'd like to have the two spatial items together, we have a few options within Petrosys to do this. The first I'll do is I'll create a new layer, and I'll fully define this, and we'll set it up as a Petrosys polygon file. I've just given it a name, contour fault vol polygon. And yes, I'm happy to overwrite the one I had previously. So I'm going to just use this contour that we see here, and this will act as the closing contour, and I'll do this by using the trace outline option. So as you see, I can quickly just start tracing the contour as I follow it round. Moving away, I lose the contour. It helps if you click a bit as you go, but if you follow it round, it will follow. And if you notice the pointer as well, it has the pointed hand. Now this means that I'm actually picking up a feature which I can trace, which I have active within the Spatial Editor. Notice if I move across, I then have a crosshair. Now one thing you do have to be careful of, which I illustrated just there, is you have to make sure you have the item highlighted within the Spatial Editor. If not, that can create some problems for you when you start editing other features. And if you find yourself ever making a mistake with this, like so, it's just a right mouse button click and you can go back to your previous vertices. So just make sure I'm picking up the item, and like so. And I've created a polygon there that I can use for volumetrics, maybe later down the line. Now, I'm going to quickly show you an alternative way to do that as well. So, what I need to do is I'll just create another polygon. I can use the same one again, I'll just overwrite it. Yep, that's fine. And I'll just discard the one we had previously. So what I'm going to do here is I'll select my contour and I'll just copy. Right click, or alternatively, if you like to use your hotkeys, you can use Control and C. Select my polygon file and I'll just paste. Now, if I'll just toggle off those contours, and I just refresh, you can see we have a closing contour here in this polygon file. And then what I'm going to do is I'm just going to quickly use the draw tool and I'll trace just this section along the fault plane. And we'll just close that there. Now I have two shapes here, and what I need to do is combine them into the one. So again, we just use the trace outline and snap this time onto the vertices. Now you know you'll pick up a vertices, you see as I just move up a line. Yep, when you get the pointer hand again, just click, click and join those two ends. I'll just click, click, and we have a united polygon. So there's two methods just there for creating a polygon out of spatial data. We have the option and a closing contour. We have the option just to copy a contour and use that as the outer section, the closing contour, and then in this case with the fault, just trace that section of the fault and combine the two together. Now another thing I'd just like to point out as well with the Spatial Editor is you'll see a number of asterisks here, asterisks. And what this means is that currently the file that we have open in the Spatial Editor with this asterisk on it is in a temporary format. It's not been saved. if I'm then just to click the save option, you'll see that asterisk disappears. If I was to then try and close the spatial editor, when you see the asterisk, you will be prompted if you want to save or discard an item. I'm just going to cancel. And we're just going to look at some of the operations that we have available within the spatial editor now. No longer need that. And I'm going to use just this shape file that I have here. I'll just drag that in. And you'll see I have a number of point data sets. These represent wells that I have just digitized into a shapefile from a Petrosys WDF. And what I'm going to do with these is just show you the back interpolate option that we have within the spatial editor. And what I can do here is I can select a Petrosys grid, as I have selected here. Alternatively, it could come from a third-party data source, any of the ones named here, be it Petrel, Kingdom, OpenWorks. These are all software packages we can connect to. And then what I'm going to do is I'm just going to pick an attribute. I'm going to pick this etiv Z value I have set up already in the attributes. If you do want to create an attribute, we can just go into the attribute definition and we can just add a new attribute like so. Double click to define it, choose the type, and then once that's created with the option to back interpolate to it, just a case of hitting apply, we'll see that 16 values have been added. And if I just select a value and using the table-based views, we can see that that has had the value written to it. Obviously, if a value falls without the range of the grid, no values will be populated, as we see with this outlier here and this one here. Now, they're not the only operations that we have available. We can also buffer shapes as well. So in this example here, I've just added a 400 meter buffer. And again, we'll just create a new layer, a temporary layer with that. Always look at your outputs when you are in the spatial editor. Are you creating just a temporary layer or actually going to fully define what the layer is, what type, etc. If it is just in a temporary format, you will be prompted when you come to save or leave the spatial editor as to what type of file you would like. Let's get operations buffer shapes, and I'll just hit apply on that. So just apply to a single shape there, or if I hit that again, you'll see it applies to all shapes. Now you see we've got this new option available here, which is for those buffers that overlap each other. Where the shapes do overlap, we can just toggle this on and just create a single shape just from the two. Okay, I can just quickly remove those layers if needs be. So we have some other options available here, and I'll just bring this point location option up. Similar options available in the cover polygons as well, except you only have the option in the cover polygons if it, I'll just check that buffer shapes. So I just need to set those point locations again, that's why it wouldn't open up. So you see here, we are able to create these shapes around a point location. So currently I have it set up as a rectangle. It can also be an ellipse. With the point locations, if you are using it to cover a polygon, the only options you have available to yourself is the rectangle option and to have a matrix in there. Now we can also apply a level of anisotropy with these, and I'm going to do this based on an angle just 45 degrees. So you see our rectangle has been rotated 45 degrees, and if I add a ratio on that angle, I can then elongate the orthogonal shape. This could be specifically useful if you wanted to create a number of shapes around a point, maybe sort of some sort of drainage pattern, or you want to apply some reserves modeling, because once you create these shapes, you can then apply attributes to them. You could then add some sort of numerical value. These are all options that you have available to yourself. Now we're just going to sort of finish off looking at some of the fault editing that we have available. Discard those buffers. And I'll discard those as well. So I have these faults, and I just want to sort of do some editing on some of them because there's a few little issues. And the one that I have issue with is just this fault here on the left. Right, so I've got the faults here, but I'd like to just be given a bit more information about the faults that I'm displaying. And this is all easily controlled within the Spatial Editor under the Layers, Display Properties, and within here I can, for example, I'll display the vertices. I quite like to display just the flags as well. And along with those, I like to see some of the symbols. Just hit OK. So now we can see we have the top and bottom flags on the faults, and we also have these fault ticks as well. Now with this fault in question, the ticks seem to be on the sort of inside. It's just not quite defined. There's something going on here. So if I select this fault, we see it's just not being imported correctly from the third-party software, but that's no problem at all, because as in Petrosys I can quickly edit this file. I'll just zoom into this area just a little bit more, just to give me a bit more control. So you can see it somehow can move. So what I'll do is I'll just use this cut tool, and I'll just make a cut under here. So you can see it's just a double click, draw a line, and that tick's now disappeared because we've cut the fault. This point here, and we'll just cut it below this point here also. Now, just to make my life a bit easier, I'll just toggle off those flags. See, they're just getting in the way a little bit. I'll just zoom in. So what I'm going to do is I'll just make sure that I'm snapping to these vertex. Now it's getting a little bit complicated around here with all the vertices, so I'm just going to use the eraser tool. Oh. And I'll just erase some of these points around here. And I'll just draw them back in. line. Oh, again, just right click over. Let's put a point in here. And the same again. Just with this. So you can see I've created the two faults from that single fault. And we see the ticks now are displaying on the correct sides and are not twisted as we saw before. Now, as mentioned before, there are right mouse button options that you can find under the tables, and I'll show you some of them just here. So I'll select this fault because it's a slightly larger fault. Now, there might be sides where you have your tops, times when you have your tops and bottoms attributed to the wrong sides of the fault. And in this case, we just have the option if you right click, and you can just swap sides just like that. Alternatively, there might be times when you're defining a fault and it's not a normal fault like we see here, it's a thrust fault, and you want to display that. So when displaying thrust faults in a mapping scenario, we expect the thrust symbols to be inside the fault. So we can do that by using the invert option, and we'll see that the ticks are therefore being displayed inside the fault. And we can define it as well just by using the symbols, and there we go. We can choose the filled thrust, and we have the triangles there that donate a thrust fault. Just by that slight bit of editing, we can quickly change our faults. We can actually maybe put some of the geological knowledge we have on an area and display that on a map and communicate that to whoever is reading it. So they're just some of the sort of little tips and tricks that I have for the Spatial Editor there. And that is the end of the demonstration. We'll just jump back into the PowerPoint to finish up. So really sort of the final thoughts, we can use the Spatial Editor just to edit and create any spatial data types. It's a means as well to sort of impose your geological knowledge as well on this data. If something doesn't look geologically correct, or alternatively you have geological knowledge that you know that needs to be imposed onto an area, you can do all that with the Spatial Editor. And then ultimately you may take that into the surface modelling and use the Petrosys algorithms to grid up that data. And then also be aware as well with the Spatial Editor, there are those operations that we touched on as well with the back interpolation, the buffering, creating shapes to cover other shapes or at point data sources, and also just some clipping based on a polygon or any other spatial data type, and being able to sort of clip out sections or create polygons that maybe have holes in, for example. So that's the end of the webinar there. If you do have any questions, I'll be here for a number of times just to answer those. Alternatively, we do have the support email or the info email where questions can be directed to as well.